Hello everyone, my name is German and the title of my talk is Listening to the Sound of Spinning Fans to make jet engines safer, less noisy and more efficient. Most of us love traveling, visiting distant places, seeing impressive landscapes and foreign cultures. For this, we rely on air transport. At the same time, we want our flights to be cheap, environmentally friendly and most of all, safe. Things which can be hard to combine. Fortunately though, research and engineering of jet engine technology come to our rescue because they target exactly these goals. Now, my research docks right on the middle of the development process for new jet engines, namely mechanical spinning tests of engine components like a rotating fan, for example. The goal here is to determine so-called modal parameters of the tested component because these values characterize the dynamic behavior of any mechanical structure. To illustrate that, let's imagine two different bells. Now you would expect that each bell will produce a different tone when hit by a hammer. This tone is known as the natural frequency, and it is one of the modal parameters that can be measured. So the sound you hear comes from the characteristic vibration of the specific bell. The same is true for an aircraft fan. And maybe you once had an odd feeling when you heard strange noises during a flight. You see, these vibrations are the reason, and they have to be analyzed. This is where I come in, because unsurprisingly, there is a difference between a bell and a spinning fan. You want to test a spinning fan, but you really don't want to hit a spinning fan with a hammer. So in my research, I want to develop a method for proper estimation of modal parameters in such challenging conditions. Instead of an external force, like the hammer, the idea is to use the vibration from the rotating motion of the fan itself at different rotating speeds to have enough variety in the excitation. But why exactly do we need to know the modal parameters of a fan, you might ask? Well, it is important to characterize the vibration so engineers can minimize it. For example, by matching the vibrations across all engine components and different operating conditions of the engine. Firstly, this avoids unwanted noise, but strong vibrations can even damage parts of the engine, and this is why it is also crucial for increased safety and reduced maintenance costs. To sum it up, my aim is to create a data analysis method for a deeper understanding of a tested component's behavior. This data is the foundation for engineers to design the future jet engines we are looking for. And this is how I want to use the sound of spinning fans to help make our flights cleaner, less noisy, more efficient, and safer. Thank you.